In section 1.5, we're going to look at word problems that involve solving quadratic equations. Earlier, we had seen a problem that involved perimeter. Now we're going to see problems that involve area as an example. For example, suppose the length of a particular rectangle is x, and its width is x plus 2, and its area is 48. And of course, for a rectangle, the area is length times width. So, x times x plus 2 equals 48. Go ahead and distribute, move things around, and we have a typical quadratic equation to be solved. This one can be factored into x plus 8 and x minus 6. Solving for each one gives us the opposites. X plus 8 gives us the x minus 8. X minus 6 gives us the x equals 6. Now, please note that whereas we have our two answers, in this case, we're talking about a rectangle. And so saying a rectangle has a width of -8 makes no sense. And so that answer won't actually be accepted. Only the x equals 6 will count. And so 6 here, 6 plus 2, 8 there. Our length and width would be 6 and 8. Another example is using Pythagorean. A squared plus b squared equals c squared. For any right triangle where the sides a and b are the shorter sides of the right triangle, and c is always the hypotenuse, it's always the side opposite the right angle. And now the problem just becomes a matter of which side are we solving for. So for instance, in this first example, we are given the two sides, the 6 and 8, and want to solve for the hypotenuse. So 6 squared and 8 squared equals c squared. We end up with c has to be 10. On the other hand, in this case, we are given the longer one, the hypotenuse, and so we have to solve for one of the other sides. It really doesn't matter which way you want to do it. If you want to go, this is A and this is B, or this is A and that's B. The point is one of the two shorter sides is what we're going to solve for. And in this case, B squared equaled 28. And so when we take the square root of 28, 28 of course is 4 times 7. Square root of 4 gives us the 2. 7 is not a square, and so we end up with 2 root 7. Making diagrams in each of these cases can really help. And then in our last example, we have an equation that is for projectile motion. That's for, for instance, the flight of a ball in the air. Minus 16t squared plus v0t plus s, where the v0 is the initial velocity and s is the initial height. For instance, think if you're throwing a rock. Well, it makes a difference if you're on the ground throwing the rock or if you're on top of a cliff throwing a rock. And so that's what the s part is for. Anyway, here we have an example in which the initial velocity was 96 feet per second, and we want to know how long is the cannonball in the air when it was fired from a platform that was 256 feet above the ground. So note how the S became the 256, the V0, the 96. Here's our quadratic equation. Again, anytime you have a squared term, it's a quadratic when that's your highest term. Rearrange a little bit to put it in a regular order. It turns out all these are divisible by 16, so that gives us a slightly easier thing that is factorable in this case. It's not always factorable, but it is factorable in this case. Solving, we get t is 8 and t is -2. Of course, the -2, the t is time. So how do you have negative time? So that answers out, but t is 8 seconds for how long it was in the air. All right, so let's look at a couple of examples now real quick. We we have the length of a rectangular room is 3 feet more than its width. If the area of the room is 160 feet, find the dimensions of the room, round the dimensions to the nearest tenth of a foot. You will often get problems like this, which just means probably you're going to have a square root when you go to solving it, and then they want you to round it to the closest place. Now, as mentioned before, it really helps to make yourself a drawing. So we first got the length of the room is 3 feet more than twice the width. So if that's the width, then we're going to have 3 plus 2w, 3 more than twice the width. And again, I could have used x's too, just as long as I can separate what the two are. And of course, length times width equals area. So in this case, my length, 3 plus 2w times w is going to equal 160. Distribute. Rearrange. And now I have my problem to be solved. Now, this one may be factorable, but again, anytime they tell me round to the nearest tenth, it's probably not going to be. So I'm just going to go ahead and go straight to using Pythagorean. And so I will have that for plugging things in. This will get me to note negative, negative, so that'll become add. And again, I'm going to estimate, so basically this is going to be 35.8 when I take the square root of that, not quite the 36 all over 4. So note, negative and negative would give me a negative width. That makes no sense. I'm going to do the negative 3 plus the 35.8 all over the 4, which is going to give me about 8.2. And so the length then will be 19.4. So an example of solving a quadratic to find the length and width of a problem. All right, next off, we have a 12-foot ramp leads to a doorway. The height of the doorway is 8 feet less than the horizontal distance covered by the ramp. How high is the doorway? Round to the nearest tenth of a foot again. Now, it can really help to make a diagram for what is going on. I have a ramp to a doorway. Okay, they tell me it's a 12-foot ramp. Okay, 12-foot ramp. So there's the 12. And that the height is 8 feet less than the horizontal distance. So if this is x, that's going to be x minus 8 there. Using Pythagorean, basically we're going to have x squared plus x minus 8 squared equals 12 squared. So this becomes x squared minus 16x plus 64. Again, don't forget, anytime you have x minus 8 squared kind of thing. It means this. So the x times x gives me the x squared, x times the negative 8 times the x, and then 8 times 8. These two gave me the negative 16 that's there. All right, again, doing a little bit of rearranging, moving the 144 and over. I'm going to have 2x squared minus 16x minus 80. They're all even, so I can divide them all by 2 to make it smaller. And again, I'm going to use to do Pythagorean. So x is going to equal a plus or minus square root of 8 squared, 64. Note this is negative. So 4 times minus of 4 times the 40, that's going to be 160 all over 2. So this is going to be 8 plus or minus 224 all over 2. So this is going to be 8 plus or minus, that's almost 225, which means it's almost 15. Yeah, 15.0 to the 10th place. I'm not going to use the 8 subtract 15 because that would give me a negative number for the distance. So I'm going to have 8 plus 15 all over 2, which is about 11.5. Now, please note, I have solved this, but come back to my drawing. This is the 11.5. This is going to be 11.5 minus 8, which is 3.5, which is the answer the problem wants. Always have to make sure and answer exactly what the problem wants. All right. Next up, Victor flew to a city that was 700 miles north and 2,400 miles to the east of his starting point. How far did he actually fly? So again, make a picture. Here's the north part. Here's the east part. Again, north, south, east, west. And so there's what we want to solve for. And a squared plus b squared equals c squared. So 700, 2,400. This comes out to 62.5 and 4 zeros. I guess I should say, since I gave that the C there. Square root of both sides, and we end up with the actual distance traveled was 2,500 miles. Excuse me. All right, our last example. A projectile is launched from the top of a 384-foot building. Its initial velocity is 160 feet per second. About how many seconds will it be 700 feet above the ground? How long will it take to hit the ground? So, again, from our earlier part, this is what we started with. So, we're 384 feet. Above the ground, and we're starting at 160. But in this case, we want to know when we're at 700 feet. So after how many seconds will it be 700 feet above the ground? So we're going to solve for t, but we want to know when that height is 700. So we have negative 16t plus 160t. Subtracting the 700 will give us 316. I'm not going to worry about doing anything. I'm just going to go ahead and go a equals negative 16, b is 160, c is negative 316. Go right into Pythagorean for this. And so t is going to equal negative 160 plus or minus 160 squared minus this will end up being, let's see, 2224. Please note that both A and C were negative, and so minus 4AC, 3 negatives will make nets, and then the whole thing would be over negative 32. Won't go through all the details, but basically we're going to end up with negative 160 plus or minus 73.3 all over 32. And so t will equal 2.7 seconds and t will equal 7.3 seconds. And if you like 2 times, well, think about projectile motion. It's going to go like that. And so here's our 700 feet. And so this time here was the 2.7 seconds, and this time over here was the 7.3 seconds. And that's the amount of time that it was at least 700 feet. These 2 times. Before it was less, and afterward it was less. Second part is how long will it take to hit the ground? So in that case, instead of what we used to begin with, which really was doing all of this, hitting the ground, it'll be at 0 height. So instead of 700, we would have minus 16t squared plus 160t plus 384 equals 0. We can divide everybody by 16 in this case. So we're left with, that'll be a minus. Minus, because we're taking out a negative 16. And so that's 24. This factors into t minus 12 and t plus 2. This one will give me a negative time. That one will, sorry about that. That one will give me a positive time. So it will be in the air for 12 seconds. And again, can't use that answer because that'll give me negative time. So this is how long it will be in the air. So some examples of solving quadratics, in this case had to use Pythagorean quite a few times for real life situations.